Season 2, Episode 3 of Dr. Phil.
Now, for our star guest, Danielle Bergoli and her mother, Barbara Ann.
Oh, and all these Joes be out here laughing like it's so funny.
What do you mean by Joes? What's the problem to be on the show?
Well, we have a lot of problems.
No,
but...
she lied.
Oh, sit
She lied.
down. I flipped you once, I can flip you again. The real problem is we need to find the glucose.
Looks like you need photosynthesis.
What's that?
Well, the reactions needed for photosynthesis are carbon and water. These reactions are obtained through a combination of pores and leaves and root systems in the ground. These are eventually, through a process, turned into oxygen and glucose. So to find that, you're going to need to go outside.
Catch me outside. How about that?
What does that mean?
What I just said.
Hold on.
Sorry, she does that a lot.
Okay.
Catch me outside. How about that?
Sit down.
First, you need to know the steps of the light-dependent reactions. Okay, so here they are. Listen carefully. Light energy excites electrons in chlorophyll A, molecules of photosystem II. The electrons are shot out of photosystem II down the electron transport chain. Protons are moved into the thylakoids as a result of the energy loss.
Pay attention.
Photosystem I then absorbs light and shouts out electrons. At the same time, water split into protons, electrons, and oxygen. The released electrons then change to NADP+ into NADPH, which is used in the Kelvin cycle. ATP is synthesized when protons are pumped through ATP synthase from inside the thylakoid to the stroma. Now, here are the steps of the Kelvin cycle, which are very important. An enzyme combines CO2 from the stroma with the 5-carbon molecule called ribulose bisphosphate, RUBP, forming an unstoppable 6-carbon molecule. This unstoppable 6-carbon molecule immediately breaks down into three carbon molecules known as 3-phosphoglycerate. Then, 3 PGA molecules are converted into another 3-carbon molecule called glyceraldehyde 3-phosphate, G3B, while using 6 ATPs and 6 NADPHs for energy. One of the G3P molecules leaves the Kelvin cycle and is used to make carbohydrates. The remaining G3P molecule is converted back into RUBP using 3 more ATPs. RUBP molecules then enter the Kelvin cycle again. The connections between those two processes, the light-dependent reactions and the Kelvin cycle, is that the light-dependent reactions makes ATP and NADPH so they can be used for energy in the Kelvin cycle to ultimately make the glucose, which is your problem. Now, for your final answer on how and where the products of photosynthesis are made, in membranes of the thylakoids of the chloroplasts during the light-dependent reactions, water is split to get electrons and hydrogen ions. The oxygen is not needed, so it is released. Glucose is made in the stroma of the chloroplast during the Kelvin cycle. And that would be the answer to our problem here.
I'm so confused. Can you explain that again?
What I just said.
Swing the remix god!
How about that? How about that? How about that? How about that? Catch me outside. How about that? Catch me outside. How about that? Catch me outside. How about that? How about that? Catch me outside. Catch me outside. Catch me outside. How about that? Catch me outside. Catch me outside. What I just said.
What does that mean?
What I just said.
What does that mean? What does that mean?
What I just said.
Sit
Catch me
down.
outside. How about that? How about that? How about that? Catch me outside. How about that? How about that? Catch me outside. How about that? What I just said.
What does that mean?
What I just said.
What does that mean? What does that mean?
What I just said.
Sit down.